Hi all. In this demonstration, in this video, I'll try to demonstrate how HAProxy, the default load balancer feature of AKS Hybrid, is working. If you click this URL, it's going to redirect you to the documentation of load balancer settings in AKS Hybrid. So HAProxy is the default installation, load balancer installation in AKS Hybrid. So to demonstrate the load balancer, if you go to my repository, which is github/pamir, and there's a link to Kubernetes Essentials. In the Kubernetes Essentials, let's click the services. In the services, we have front-end service YAML file, and let's try to deploy this YAML file. But please, let's focus on the load balancer because there are three types of service types in Kubernetes. One is cluster IP, the second one is node port, and the third one is load balancer. And if you deploy service type load balancer, it will get an external IP address. And so by this way, there will be an IP address which is assigned to HAProxy server. So let's deploy it. But before that, before deploying the HAProxy, I want you to show you something on the in our cluster. So this is our load balancer VM, and if you look at that carefully, there are two IP addresses. Let's focus on. Let me execute zoom file, and if you look at the IP addresses which are assigned to the load balancer VM, there are only two IP addresses. One is for IP address of the VM. The second IP address is assigned from the virtual IP address pool, which is the load balancer IP address, and this is the IP address of the API server actually. And let's deploy our service, kubectl apply -f and the path of the YAML file. After deploying this file, we're going to observe that get service one IP address kubectl get service. We're going to see that a new IP address assigned to the front-end IP front-end service. So again, if you focus on the IP addresses of the load balancer, you're going to see that 152 IP address assigned to load balancer VM. So how it's actually working. So let's draw our Xcali draw. Let's open Xcali draw, and there is an underlying service. We discussed it earlier in the videos, Cloud Agent. So this is a singleton Windows service on our Hyper-V environment, and it can be one or two StackCI or Windows nodes, StackCI or Windows. This is actual physical hosts, and let's make it for physical node Kubernetes cluster. So Cloud Agent is running on top of these services. It's a singleton Hyper-V service. On top of that, our target cluster is working, but first of all, we need to have a management cluster in here. And for that process, management cluster is not responsible for anything. Management cluster. And we have our target cluster, but in the target cluster, I will draw it a little bit bigger. So this is our load balancer VM. And we have our worker nodes in here. Worker nodes. And let's go again. Let's execute kubectl get pods -n kube-system to assign this IP address. The important pod which is running on the master service is the MOC Cloud Controller Manager. So it's a controller pod, and this controller pod is actually looking for load balancer type services. If it catches a load balancer service, then it initiates to assign the IP address to the VM. So first of all, we have the MOC Cloud Controller, not this one. I will write it instead of worker node. I will say that master nodes. So we have this small pod inside the master server. Let's make it purple. And let's write its name, MOC Cloud Controller Manager. So it is actually looking for new services. Let's draw something like this. It is a for loop and looking for load balancer IP address, which is load balancer type services in Kubernetes cluster. When it sees that, it sends a request to Cloud Agent, and Cloud Agent is directly talks to the load balancer. And in the load balancer, we have 3 important services for load balancing operations. We have HAProxy, and for multi load balancer options, we have KeepAlive, the service. And there's one more service in here for Cloud Agent to communicate and they update the HAProxy, which is LB Agent. And LB Agent updates the HAProxy files. So by this way, from the client, after that, this one, if you communicate to the load balancer VM, by this way, it understands that there's a new service which is deployed to the target cluster. So the flow is this way. So you update your kubectl file with a load balancer type service, and MOC Cloud Controller Manager watches load balancer type services. If a new service is deployed, Cloud Controller Manager sends a request to Cloud Agent. Cloud Agent then assigns an IP address and do the calculation kind of stuff, and then sends a request to LB Agent. LB Agent updates the HAProxy file. So if the client tries to connect to the new assigned IP address, that is how it is done. So let's check and then connect to our environment. So let's get the VM's IP address of the load balancer, which is 04. And let's connect to this SSH to connect to load balancer. Again, get MOC config. I need to get the private key. So SSH-I, the path of the private key, and then the username to connect to the load balancer is cloud user. And then let's type the IP address of the load balancer, which is 04. Let me check one more time because I forgot it. Okay, it's good to go. Cloud user. So let's switch to su, which is root. And then let's type the service. I want to list all the services in the load balancer. The command is systemctl --type, which is service. Right now I'm listing the services in the Linux. not related with the Kubernetes. I'm trying to show you the essential, the vital services which are running in the load balancer dash state, which is running system. Okay, so there are three important services to this load balancer to work. One is HAProxy, this one. If this service is down, you cannot connect to your load balancer, your API server. And KeepAlive D is a complementary service for HAProxy. And this service is very important, LB agent. If the LB agent is down, then no new IP address will be assigned to your environment. So these three services is vital for load balancer flow to work successfully. And if we execute netstat-tcp UDP port listening number, we're going to see that bunch of ports are open for load balancing operations. HAProxy is actually listening for the background services, so it is not the actual port number. But LB agent port number is very important, which is 46,000. So we should write that LB agent port number is 46,000 to here. And the MOC Cloud Controller Manager talks with Cloud Agent through two port numbers, which are 65,000, and the other one is 55,000. So 65,000 port is for authentication and authorization, auths, and 55,000 is for actual requests. So be careful about these port numbers in production, because if there's a firewall rule inside here, so we will have problems in the load balancing operations. So Cloud Agent sending the request, first one, this one, and the second one is Cloud Agent is sending request to the LB agent, 46,000. Again, let me repeat myself, is place the HAProxy file and then restart the service if necessary. So there is a systemctl after the file is updated, reload or restart HAProxy is executed after a new service is discovered or any service is deleted. So this is the actual flow of load balancing operation in AKS Hybrid. Thank you so much.